Hello learners, and welcome to today's lesson of financial mathematics. Let's get to our lesson. So we know that when it comes to financial mathematics, these are the concepts that are worked around when it comes to mathematics. But for this lesson, we are just going to focus on these four concepts. Let's look at what we are going to address by the end of this lesson. Using the simple and compound growth formula to solve problems, using the simple and compound decay formula to solve problems, calculating the effective of different compounding periods on the effective interest when given the nominal interest, and using the future value formula for annuities and savings, and calculating the outstanding balance at any given time, using the present value formula for loans, and calculating the sinking funds. So those are the things that we are going to address in this lesson. Now, when it comes to the keywords, these are the keywords that you are used to using and used to seeing when you are working with financial mathematics. And here are more of those keywords when it comes to financial mathematics. Let's look at the common content and skill errors and misconceptions. Well, firstly, the learners do not know which formula to use for different scenarios. So you need to make sure that you will know which formula to use when you are faced with different scenarios. Learners do not use the formula sheet, therefore they write the formula incorrectly. So you need to use the formula sheet because these formulas are provided. And lastly, learners do not know how to correctly interpret the information given in order to answer the question. So we need to properly read those statements so that we can properly answer the question. Let's look at what you should know or be able to do from grade 10 and 11. That is how to calculate simple interest and compound interest, how to calculate simple decay and compound decay, how to calculate the effective interest from the nominal interest, or how to calculate the nominal interest from the effective interest. And then what you should know from grade 12 or be able to do is how to calculate different annuities, also how to set up a sinking fund, right? And how to calculate the outstanding balance, and also how to calculate annuities if they are missed payments. So those are things that you should know from grade 12. Then, of course, we have those skills that you need to sharpen when it comes to the exam, because you need to make sure that you answer those exam questions precisely, and accurately. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to go into the first two concepts of our concept map, and that is simple interest and compound interest, as well as simple decay and compound decay. So looking at the content and skill problems is that learners do not know which formula to use, and on top of that, learners do not know how to substitute correctly. So that is an issue that needs to be fixed before we can go into that exam room. And when it comes to the exam, learners do not use the formula sheet to write down the formula. So you know which formula you want to use, but you do not use the formula sheet to write down that formula. Please use that formula sheet. And again, learners struggle to interpret those questions. Let's look at the key theory aspects when it comes to this part of financial mathematics. So you need to know how to calculate simple interest and compound interest, how to calculate simple decay and compound decay, and also how to use log to work with exponents. So we need to know how to work with these features here. Let's look at a first example. Mrs. Gumede puts 3,500 Rand into a savings account which pays 7.5% per annum compound interest. After some years, her account is worth 4,044 Rands and 69 cents. For how long did she invest her money? So we have been given information here where we have the amount that was put into the savings account. We have the interest that was charged to that savings account, or the interest that is gained in that interest in that savings account, and also we have the amount that will be obtained after some years. So the question is, for how long was this money in that account? So we know that we are looking for the number of years. So let's look at how we would answer this question. Well, firstly, we need to choose a formula. And in the statement, we have been given there that it's a compound interest. Now, remember, if it is a compound interest, then we use the formula that says A is equals to P, open bracket, 1 plus I, close bracket, exponent N. Then we just need to substitute our values. And in this case, if we are looking at the future value is the money that is obtained after these number of years, and that would be the 4,044 rands and 69 cents. When it comes to the present value, that is the money that was invested now, which is the 3,500 rands. And of course, we have our interest, which is 7.5%. And then we have the number of years, which is what we are trying to calculate. So when we substitute there we've substituted our future value, our present value, and of course our interest, which is 7.5%, or 7.5 divided by 100. Now you can see that the unknown value here is the N. So that is what we are going to calculate now. So we're going to start by dividing both sides by 3,500 so that we can be left with the bracket alone, but we can also calculate what is inside that bracket there, and when we've calculated it, it gives us 1,075. And of course, when we have divided on the left hand side there, that is the answer that we get from those values being divided. Now, how are we going to solve for that unknown, as it is an exponent? Well, if you remember your knowledge there, we know that to bring down an exponent, we need to introduce the log function. So we are going to introduce log there. We know that log brings down the exponent. There is our N there. And when we divide both sides by log 1,075, we know that our answer for log, or our answer for that calculation, is going to be 2, which means that this money grew by 7.5% per annum in 2 years, of course, using that compound interest. Let's move over to the next question. The next question says that a car worth 120,000 depreciates at a rate of 12% per annum on a straight line method. How much will the car be worth after 5 years? Now, by now you should know that the straight line method refers to that simple interest, but we are going to be working with the simple decay because our value is going down. So we know that that's what we're going to work with. But now, looking at the values that we have, we do not know how much the car will be worth after those 5 years, but we do know what the car is worth now, and that is 120,000. And then when it comes to the interest, we can see that it is 12%, which is 12 divided by 100. And of course, our N is going to be the 5 years, because we are asked how much the car will be worth after 5 years. So the formula that we're going to choose is that of the simple decay. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to be going into that last concept of our concept map, and that is annuities. So let's get to our lesson. So when it comes to the content and skill problem here, is that learners confuse the formulas that they're supposed to use. So you can see that formulas are a big part of financial mathematics, because if the formula is wrong, you will not receive those marks. Then when it comes to the exams, learners do not know how to interpret those questions, and also learners are not using the formula sheet when writing down those formulas. So make sure that you use that formula sheet and practice more so you can know how to interpret these questions. So when it comes to those key theory aspects, so these are things that you learn from grade 10 right up until grade 12. It says there the future value formula is used when you pay equal installments in order to save money for the future. And then the present value formula is used when you have a lump sum of money, either a loan or inheritance, and you want to calculate how much the equal repayment amounts will be, or to calculate the outstanding balance. That is when we use that present value formula. But let's look at examples for a better understanding. The example there says, a farmer buys a tractor for 450,000 rand. So now we are going to look at questions that are concerning this farmer that bought this truck at 450,000 rand. Now, the first question there says, how much will the tractor be worth in 5 years' time if its value depreciates at 9% per annum on reducing balance? So we underline those keywords and we think about what is actually happening to the price of the tractor. Now we know that if we buy something, what will happen to the value of that thing that we bought? It will decrease, which means that the answer that we are expecting must be less than this 450,000. So we are going to go ahead and choose a formula that we are going to work with. Since as well we are told that it is reducing balance, we know that that is the formula for a compound decay. So there we have the formula there. And then when we substitute the values, well, firstly, we don't know what the future value is going to be, but we do know the present value, which is the cost of the truck right now, and that is 450,000. Now, when it comes to the interest, we are told that it is 9%, which is 9 divided by 100. And we know that the time or the period that we are looking at 5 years. So how many times is this tractor going to decrease? Well, it's 9% per annum, which means it's going to be 5 years or 5 times, because it's going to be once a year, which happens within 5 years. So when we substitute there, we can see that we have the 450,000 in the place of P, we have our interest there, and then we have our period. Then that gives us a value of 280,814.47 . Now, remember, you need to make sure that you round off correctly. So that answer there is rounded off already. And of course, we only round off when we get to the final answer. Let's look at the next sub-question in this first example. The next sub-question there says, after 5 years, so we're still working with that farmer that bought that tractor for 450,000 rand, it says that after 5 years, the tractor needs to be replaced. Now, during this time, inflation remains constant at 7% per annum. So inflation, there is the key word, and then determine the cost of a new tractor after 5 years. Now, if we think about something that we buy now, after 5 years, it will definitely not be the same price. Now, we are not talking about the actual thing that we bought, but we are talking about the newer version of this thing that we have bought. So this farmer is now going to go to a shop and try to find the newer version of this tractor so that it can replace the old tractor, because after 5 years, that tractor is going to be old. So we are going to now replace that old tractor, and this means we need to take into account of inflation, where prices increase every year. So these prices will increase by 7% per annum, and then we need to determine the new cost. So we are not told what type of interest is used here, so that means we are going to use the compound interest. So there we have the formula, and we are going to substitute. Remember, we are looking for a future value, so that means that we do not have A, but we do have the rest of the substitutions there. And that is going to give us an answer of 631,148 rands and 28 cents. Let's go over to the next sub-question here. It says he plans to sell this tractor at its book value. So he plans to sell this tractor at its book value and use the money towards a new tractor. Now calculate how much money he will need to put into a sinking fund to buy a new tractor in 5 years' time. Now we know that the book value has already been calculated, and that was the 280,000 rands. Do you remember that value? Yes, that was the 280,000 rands, 814 and 47 cents. So now we need to make sure that when he goes to buy the new tractor, he'll be able to sell the old tractor, get its book value, and use it as a deposit for the new tractor. Now, how are we going to calculate that? Do you remember how much the new tractor is going to cost after 5 years? Well, that one is going to cost 631,000 rands and 148 rands and 28 cents. So how are we going to get what amount he's going to need for the new tractor? Well, we are going to take what the tractor will cost after 5 years, and that is the new tractor. And we are going to subtract the value of the old tractor that is going to be sold there, and that is the book value of the old tractor of which we've calculated. And that is simply going to be 350,333 rands and 81 cents. So that is the actual amount that he's going to put into the sinking fund. Now, what is a sinking fund? A sinking fund is an account that will be opened to make sure that at the end of those 5 years, the farmer has enough money to buy that new tractor. But let's look at the next question. So the next question there says, calculate the value of the monthly payments into the sinking fund if the interest is 8.5% per annum compounded monthly over the next 5 years. So remember, this farmer now opens the time he buys the tractor, he also opens a sinking fund to say he's going to save towards that new tractor. But is he going to save that 631,000? No, he's going to save the 350,000. Why? Because that is how much he will need, as he will combine it with the book value of the old truck and then go and get that new tractor. Let's look at the calculations here, and more importantly, which formula are you going to use? Now, did you notice that before we got to this question, we were only working with the formulas that had our A and our P for our future value and our present value. But now we are talking about the monthly payments. And in financial mathematics, the monthly payments are represented by our X, which means now we need to look at those formulas that have X in their formula. Now we have a choice between the present value formula and the future value formula. Which one are we going to choose? Well, we need to think about this money that we are going to save up. Is it money that we have now, or is it money that we plan to have for the future? Now, if it's money we plan to have for the future, then that means we are going to use the future value formula, and there it is, the future value formula. Now, what are we trying to find? It says calculate the monthly repayments, which means we are trying to find the value of X. So that is the value that we are trying to find, which means every other value will be substituted. That is the future value that we are trying to save up for, that is the interest rate, and of course the value for N. When we substitute all of those values, the future value is 350,333 rands and 81 cents. We have an interest of 8.5% compounded monthly. So compounded monthly means that this account is going to get interest 12 times in a year, because the interest is for the whole year, but because it's compounded monthly, it is going to be split into those 12 months, and we represent that by dividing by 12. And when it comes to the period, or how many times this account is going to get interest, that will be that 5 years and 12 times each year. So that means that will be 5 multiplied by 12. Now, when we make x the subject of the formula, of course, we are going to multiply both sides by that interest that is down there, and then we are going to divide that big bracket there so that x can be alone, and that will give us a value of 4,706,010 cents. And of course, that is going to be that the monthly payments that this farmer is going to be paying into the sinking fund, so that at the end of 5 years, he has enough money to buy that tractor. Let's go over to a second example. Now, this example says, in order to buy a car, Zach needs to take a loan of 25,000 now from the bank. The bank charges an annual interest rate of 11%. So it's an annual interest rate, meaning that 11% is per annum, and it's compounded monthly, which means it needs to be split into those 12 months. Now, the installments, our keyword there, the installments, meaning we are going to choose the formulas that have X, which represents our installments. So the installments start a month after he has received the money from the bank, which is usually what happens in a normal case. And remember, our formulas are based on that fact that even if we get the loan now, the installments will only start going off a month after I've taken that money. So it will not be an immediate. So it means that our formula does not change. It remains exactly the same. So it says they calculate the monthly installments if he must pay back the money over a period of 5 years. So we are calculating here the value of X. Now, which formula are we going to use? We already know that we are going to use the formula with the X, but now are we taking the present value formula or the future value formula? We are going to take the present value formula, because what happens when you go to the bank and ask for a loan? They will give you that money and you will have that money now with you in the present. And that's why we are going to choose the present value formula. Of course, that value that you received will be the 25,000 that Zach received from the bank. The interest will be charged, and that will be 5 years. But remember, the interest that will be charged 12 times each year, which is 5 multiplied by 12. And remember, our interest is, yes, per annum, but because it's compounded monthly, it will be divided within those 12 months, which is divided by 12. Now, when we make X the subject of the formula again, we are going to multiply our value on the left-hand side by the interest rate, which is 0.11 divided by 12. And then we are also going to divide by this whole bracket. So we're going to multiply by the interest and divide by that big bracket there, just so that we can make X the subject of the formula. And the value that we are going to get there in installments is going to be 543 rands and 56 cents. And that is how much Zach will be paying every month so that he can pay back that loan that he took over 5 years. So the first question there says, calculate how many years it will take for the value of a truck to decrease to 50% of its value or of its original value if it depreciates, its depreciation is calculated at 15% per annum using the reducing balance method. So I hope you noticed here that there were no values given, but what we do know about the values is that one value is 50% of another value. So let's start by thinking about this question and thinking about what is going on here. We are working with a depreciation situation, so we are working with DK, and we know that the formula that we are going to use is going to be A is equals to P, 1 minus I, and exponent n. So when we are thinking about the information that we need to substitute, we know that the interest is 15% per annum, so that is 15 divided by 100, or that is 0.15, and then that is also the number of years, the one that we do not know, because our question says calculate how many years, so we don't know the time period here. Now let's talk about the present value and the future value. They said that the value of the truck will decrease to 50% of its value. So one thing we know for sure is that whatever the original value was, which was P, we know that the future value will be half of that P, since as well it decreased to 50% of that value. You can also write that it's 0.5 multiplied by that P, which still represents 50% of that value. So let's take our information and represent it. So in the place of A, we know we are going to write that is half of P. In the place of P, we're just going to leave it as it is P. If you're more comfortable with using other variables like X, that is perfectly okay, because in mathematics, if we do not know what a value is, we usually represent it with X. So you can put X in the place of P, but the relationship between P and A is that A is 50% of P. So we just need to remember that. So that is going to be 1 minus 0.15, and that is going to be to the exponent of n. So now that we've substituted that, well, firstly, we know that we are going to divide by P. So when I divide both sides by P, that is going to be 1 over 2 on one side, and on this side it's going to be, so those p's are going to cancel each other out. We're going to have 1 minus 0.15, which is actually 0.85, and that is to the exponent of n. Now, how do we bring down an unknown exponent? Of course, we have to introduce log. So we are going to introduce log on both sides. On this side, it's going to be log of half, and on this side, it's going to be log of 0.85. But now that exponent will come down and it will become that base and will multiply with that log. Now, how do we get to that value of n? Well, we are going to divide by whatever is disturbing our n from being alone, and that is the log 0.85. Now, a common mistake here is that when you get to the left-hand side, you are going to divide by log of a half, but that is not the case. Remember, we are going to divide by the same thing on both sides. So since as well on the left-hand side, we are dividing by log 0.85, it means on the right-hand side, we also have to divide by 0.85. And then that is going to give us n on the one side, and on the other side we are going to have an answer of 4.27. That is of course 4.27 years, and that is where you can leave your answer. Let's go over to that second question. It says there, every month Tshepo deposited 1,500 rands for his retirement into an account that paid interest at a rate of 9.2% per annum compounded monthly, right? Tshepo made his first installment on his 23rd birthday and the last installment 1 month before his 55th birthday. Now calculate how much money he had in the account on his 25th birthday. Now when we think about Tshepo's situation, we need to now be working with how long of a period is it for Tshepo here. So we know that when it comes to n, it was from his 23rd birthday right up until the 1 month before his 55th birthday. So can you calculate how many years that is? Yes, if you are thinking that that is going to be, you're just going to take the 55 years and you're going to minus the 23 years, and that is, or let's rather write it next to the n where we are actually calculating for n. So that is going to be n is equals to the 55 years minus the 23 years, and of course, yes, that is going to give us 32 years. Now, what about the other values? Well, we know that the interest is definitely going to be that 9.2% compounded monthly. So that is going to be 0,092, and that is going to be divided by 12 because it is compounded monthly. We are looking for, we have X, which is the deposits that Tshepo was making, and that is 1,500 Rand. So this information is given to us as is. What is not given is which formula we're going to use. So we need to know, are we calculating the future value or are we calculating the present value? Now, if you go back to the question, it says, calculate how much he had in his account on his 55th birthday. Now remember, when Tshepo opened the account, he was 23. Now, how much is he going to have when he is 55? That is a future value. When he opened the account, he did not have that money. But now in 32 years' time, what happened? He had the money that was now that lump sum money. So that means we are working with a future value, of which right now we don't know what it is, but we do know that we are going to use the formula for the future value. Now, when it comes to copying that formula down, please go to the back of the exam paper. There is a formula sheet there. Use that formula that has been provided for us. So that is X and open bracket 1 minus, that is X, open bracket, and we open another bracket, that is 1 plus I to the exponent of n minus 1. We are going to close that bracket. Do not forget this I that is divided there at the bottom. That is a very common mistake. So make sure you do not make the same mistake. So when it comes to our substitution, that is going to be 1,500, open bracket, 1 plus that 0,092, that is divided by 12, close bracket, and then we are going to make an exponent, which is the period. And remember now, the period, yes, is 32 years, but it means if he's receiving interest every month for 32 years, that 32 has to be multiplied by 12. So that is 32 multiplied by 12. And when we take 32 and multiply it by 12, the answer that we get there is going to be 384, which is going to be the value that we are going to substitute there, 384. And as for the rest of our formula, we are going to close that bracket, and that is going to give us a value, and that is going to allow us to divide the whole numerator by that 0,092 divided by 12. Do not forget that bottom part. Now, when we place everything into our calculator, and of course, when you're placing the things into your calculator, remember your calculator is a device. Sometimes if you're punching in those numbers too fast, then the calculator does not capture some of the numbers. So double check if every value is in the calculator. Our answer there is going to be 3,478,620 rands and 49 cents. Now, remember, because our statement says there that his last installment was 1 month before his 55th birthday, but he will only now, or rather that money stays in the account until his 55th birthday, it means that this money will stay in that account for 1 more month, which means that in that month he will gain interest. So how are we going to calculate that? Well, we are going to use our formula for the future value when there are no installments. So that means we are going to take this amount that he already has in his account, and that is
478,620, and that is 0.49 cents, with that interest that he's going to gain for that one extra month. And remember, we are keeping the same interest and it is compounded monthly, so that will be plus 0.092, and that will be divided by 12, and our period, of course, is just going to be 1 for that one extra month that amount that he had in his account is going to gain interest. And of course, this is going to give us now a final answer of 3,505,289 rands and 91 cents. And this is the amount that Tshepo is going to have in his account on his 55th birthday.
And that is going to be what Tshepo will have after 32 years of paying 1,500 into the account. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. Now, moving over to that third question, it says there, Abram has 150,000 to invest in two separate accounts. So one account pays an interest rate of 8.4% per annum compounded quarterly, and the other account at a rate of 9.6% per annum compounded monthly. Now, how much money should he invest in each account so that he will collect the same amount from each account at the end of 12 years? Now, this is where it is very important for you to think about the scenario and what is happening here. And of course, to take into account each and every detail that has been given to us in the statement. So firstly, we know that there is 150,000 Rand, and this 150,000 Rand needs to be split into two accounts. And in the end, these two accounts need to produce equal amounts. So that's basically what is happening here. So let's see, or firstly, try and decide which formula we're going to use. Now, when you read the statement again, it does not mention installments, which means that we will not be using those formulas that have an X, but we will be using our A and P formulas. So that is going to be A is equals to P, open bracket, 1 plus I, and that is going to be exponent N. Now, we know we're going to use this formula because it was not specified for us which formula to use, so we use the compound interest. And we know we're using compound interest because this is an investment. So what do we know about this money that Abram has? Well, that 150,000 must be split into two accounts, like we've said. So we know that Abram is going to take a certain amount and he's going to invest it. Now, this first account, we are told that it is going to be an interest of 8.4%, which is 0.084, and this is compounded quarterly, so it will be divided by 4. And of course, when it comes to the time period, it says there at the end of 12 years. So we know that this is going to happen for 12 years, but each year he's going to get interest every quarter, which means that that 12 is going to be multiplied by 4. Now, when we simplify that which is in the brackets, including that exponent, because the exponent does belong to that bracket, we get a value of 2,711662406, and this, of course, will be to the exponent, I am way ahead, where we have to multiply that x in, and when we do multiply that x in, that is of course going to be 2,711662406, and that with the x. Now, why do we write that answer in full? Because we know that this is just the middle of our calculation. We are not finished yet. So we That is the first account. What about the second account? Well, if Abraham took out X amount of money, the second account will get the rest. And how would we calculate the rest? That, of course, would be the 150,000. So we're going to use the same formula. But for this case, our P is going to be, let's rather write the formula first. Our P is going to be the 150,000 minus the amount that was subtracted for the first account. So that's going to be 150,000 minus X. And of course, that is going to be multiplied by 1 plus an interest of the second account. We were told it's an interest of 9.6%. So that is 0.096. That is divided by 12, since as well it's compounded monthly. And of course, when it comes to the exponent, it is 12 years, and that 12 years we are going to multiply by another 12 for compounding monthly, and that is an exponent of 144. And when we simplify that, that gives us a formula of here. We have that 150,000 minus X, because we don't know what that value is, but we do know that the value from the first account was subtracted from 150,000. And in the second bracket, we will have the 3,150,044, and that value continues there. So we are going to write the whole value to 02674, and we are going to close that bracket. Now, this is what we have from the first account, and this is what we have from the second account. What do we know about this account? We know that he wants to collect the same amount from each account after 12 years. So what are we going to do with these amounts? We are going to equate them. So that means that 2,711,662,406X must be equal to this 150,000, and that is going to be minus X. That is multiplied by 3,150,044, and that value continues there. So when we multiply or we simplify this, on this side we still have the 2,711,662,406X, and when we multiply our values here, we are going to get 4,72, sorry, that is actually incorrect. That is going to be 4,72506, 6041. You need to be careful. You need to be careful when you are writing down those values, and make sure you don't miss any number. And then that is going to be minus the 3,150,044, and we are going to have an X there. And then when we simplify this by, of course, bringing the X values to one side, on this side we still have that value of 472,506,6041. On this side, when we bring over the X there, it will be 5,861,706,433X. And when we divide both sides by that 5,861,706,433, then we are going to get an answer, or an X value of 80,609 rands and 5 cents. So that is the amount that must go into the first account. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson, where we are going to wrap up this lesson that we've had on financial mathematics. Let's look at the concepts that we were looking at here. Now remember, financial mathematics does have more concepts, but in this lesson, we were only able to focus on the simple and compound interest, the simple and compound decay, as well as the nominal and effective interest rate and the annuities. So those are the only ones we focused on in this lesson. Let's look at the keywords that you are going to be using or that you are going to be seeing when you are reading a question paper. These are the words that you're going to be seeing very often, and you must know what they mean or be able to relate to how you can use them to answer your questions. Of course, we have those common errors that you should make sure that you do not make these errors or the misconceptions which hopefully have been straightened out. Well, learners do not know which formula to use with different scenarios. So hopefully now you know which formulas to use when faced with a particular situation. Learners do not use the formula sheet, therefore writing down the wrong formula. So make sure that you use that formula sheet. It has been provided for you so that you can be able to use that formula sheet. And then lastly, learners do not know how to correctly interpret the information given in the question. Remember, the smallest of details is important. So you need to make sure that you read the statement properly and try and understand the scenario before attempting to answer that question. Now, don't forget those skills that you have to keep in mind when you are in the exam. The more you sharpen these skills, the more you will flow during the exam. And lastly, of course, you need to practice, practice, practice. And here you can see those are the few questions that you can use to practice these concepts that we were working with today. And of course, you can also use more papers that you can use to practice and get better in maths. Thank you for joining us in this wonderful lesson. I enjoyed it and I hope you did too. We hope to see you next time. Goodbye.